Hello, in this video we're going to learn to verify identities using the fundamental identities. What are the fundamental identities? Well, I've listed them here. The first one we've done since Chapter 1, the reciprocal identities. I won't show you how to get those because we've seen how to do those in Chapter 1. Cotangent we know is 1 over tangent. Secant we know is 1 over cosine, and cosecant is 1 over sine. The next one is the quotient identities, where tangent is sine over cosine. Cotangent, because it's reciprocal and they're the reciprocals of each other. Cotangent, reciprocal of tangent is what I was trying to say. We know that it's cosine over sine. Let me go ahead and show you the first one. To prove this identity, I'm going to start with sine over cosine and use the definitions of sine and cosine from the very first chapter. And tangent, by the way. Sine theta we know is y over r by definition, and cosine we know is x over r. If I multiply both sides by r to get rid of the complex fraction, the r's cancel and you end up with y over x, by the way, which is tangent of theta. By the way, another way you could have thought of this is y over r divided by x over r. And we know dividing, you multiply by the reciprocal, and the r's could have canceled that way as well. And cotangent could be done a similar way. The next grouping is the Pythagorean identities. The first one we've seen from the first chapter. Sine squared of theta plus cosine squared of theta is 1. This can be proven a similar way. This would be y over r, but we square it. This is x over r, and we square it, starting with the left side. So that would be y squared plus x squared over r squared. But since, if you remember, we're dealing with a right triangle, we should do it over here, right triangle, x, y, and r, we know that this is just equal to, let me do it right here, r squared over r, which equals 1. From the fact that in a right triangle, x squared plus y squared is r squared. So you can see that it does work. In fact, of the 3 Pythagorean identities, this is the only one you really need to memorize because the other 2 are really easy to get. What I'm going to do is start with the sine squared plus cosine squared. Sine squared of theta plus cosine squared of theta equals 1. Okay, so what you're going to do to get the second one is if you divide everything by cosine squared, every single term by cosine squared, what you would get is a tangent squared theta plus 1 equals secant squared theta. Since sine over cosine is tangent, cosine squared over cosine squared is 1, and 1 over cosine is secant, so 1 over cosine is secant squared. And then you would have the second one. To get the third one, you just divide everything by, we'll do it over here, divide everything by sine squared. So we'll start with the first one, dividing everything by sine squared. What do you get? Do you get it? You sure do, because this would be 1 plus cosine over sine we learned was cotangent, so this would be cotangent squared. 1 over sine is cosecant, which, by the way, is cosecant squared. So that gives me the third one. The negative angle identities we won't be going over in this video. So using this, let's go over our first question. Our first question is, verify that the trig equation is an identity. So we have this equation here is an identity. To prove something is an identity, what you need to do is you need to start with one side, manipulate until you get to the other side. So I'm going to go over the hints first. I have them listed on the right hand side. First, it says to learn the fundamental identities and substitute one of these identities whenever possible. It's always good to try to start with a more complicated side. And then what you're going to do is you're going to continue on. If I go to the end, all these are different helps. And as you select your substitutions, keep in mind that you are not changing. Keep in mind the side you're not changing. So again, you're going to start with one side, try to get to the other side without changing the other side. You don't change the other side because that is your goal. Okay, so let's do that. Are you ready? So what we're going to do is I'm going to start with the more complicated side. Well, since both of these look just as equally complicated, I'm just going to start with the left side, but I could have just as easily started with the right side. And I'm going to try to substitute one of these identities. The next line, let's just go ahead and read the next line. It says, sometimes it is helpful to express all trig functions in terms of sine and cosine. Well, this secant right here is blaring at me, and I can change that to sine and cosine because we know secant is 1 over sine. 1 over cosine. So let's go ahead and write that. So I'm going to leave everything the same except for secant. I'm going to change to 1 over cosine. I still have that minus 1, and the numerator stays the same. Now, my next end. Always try to simplify and factor. So if you can simplify, you should do it. And in this case, to simplify, I don't like this double fraction. So I'm going to do the same trick as I did above and multiply top and bottom by cosine of theta since it's in the denominator. And that will give me cosine squared in the numerator. In the denominator, when I use the distributive property, the cosines would cancel when I multiply the first together and give me 1 minus cosine of theta. Remember that my goal, let's remember our goal again, is to get to the right-hand side. It doesn't look like we're anywhere near it. So let's keep on going with our hands. If one side contains more than one fraction, right, try rewriting as one fraction by getting LCD. Well, since it doesn't have more than one fraction, I'm going to skip that for this problem. But if ever that happens, that's a great hint. And then we're going to do this one. If an expression contains 1 plus or minus sine or 1 plus or minus cosine, it's good to multiply both numerator and denominator by its conjugate. And we do in the denominator here have a 1 minus cosine. So let me go ahead and rewrite it so I have more room. And there's our 1 minus cosine. I'm going to multiply it by the conjugate, which by the way is the same expression but with the plus sign. That's what conjugate means, if you remember that. 1 plus cosine of theta. And what do you get? The numerator, I am not going to multiply that numerator because again I'm remembering my goal. Notice how the numerator already has a 1 plus cosine, so that is our first success. We got that there. So let's go ahead and leave it. And the denominator, what we're going to do is we're going to go ahead and multiply that because we do not have either one of those terms there. So I'm going to use FOIL first. Now the outer and the inner, the terms go away. Here the outer gives you a 1 times cosine of theta. This gives you a negative cosine of theta, which goes away. So finally, I'm going to do the last term. First, outer, inner, last. That would give me a minus cosine squared theta. That looked a little sloppy, so let me go ahead and rewrite that. So I took the 1 times both of them and the cosine times both of them. So there was the 1, the outer was positive, negative went away, minus cosine squared. Now it's always good to recognize 1 minus cosine squared is just sine squared. Let me scroll down to show you why that is. So if I have, for instance, our main Pythagorean identity, sine squared plus cosine squared equals 1, and I subtract both sides by cosine squared of theta, what do I get? I get that sine squared theta equals 1 minus cosine squared theta. And I can erase these because we don't need those. You could do the same thing by subtracting both sides by sine theta. You would get cosine of theta square root of theta equals 1 minus sine squared theta. So it's good to memorize these identities as well, which is just transforming sine squared plus cos squared as 1. So if I look at this, I realize that that is sine squared theta. So let's go ahead and write that. So the top, again, I'm going to leave alone. And the bottom, I'm going to call sine squared theta. And again, let's scroll back up, look at the original, see if we're getting close. So believe it or not, we really are close because cosine over sine is cotangent. And 1 over tangent is cotangent. So I can tell that I'm really close. So I'm going to do something a little tricky here to get that cosine on the bottom. Because remember, that is my goal. I'm going to multiply top and bottom by 1 over cosine squared of theta. Whenever I do the numerator, just like I multiply top and bottom by cosine there, as long as I do it to the denominator, it's not changing the fraction. And the numerator, the cosine squares cancel, giving you, there it goes, giving you 1 plus cosine of theta, which is exactly what I have in the numerator. That gets rid of that cosine squared there, and then we have a sine squared theta over cosine squared. And we know from one of our identities, if you scroll up, scrolling up, we know that sine over cosine is tangent. Sine over cosine. So that is equal to, again, thinking of my goal, so I'm going to put this time the cosine first. Cosine theta, cosine of theta plus 1 to get exactly the right side. And then this would be a tangent, sine over cosine of tangent, so we have a squared there, theta, which is indeed, if you look there, it almost can't get in one screen, but you can see the numerator is 1 plus cosine, we have that. And then the denominator is tangent squared, 1 plus cosine, tangent squared. We indeed just verified the identity. Now, sometimes you might get stuck in the middle here. If I got stuck and couldn't see the answer to multiply top and bottom by 1 over cosine squared, I might have started with the right side, which is what the note talks about. Let's talk about this note. Working with both sides is sometimes a good alternative for identities that are difficult. If one side does not seem to be effective, just switch to the other side. So don't give up on these. These are puzzles. Sometimes you get it quickly, sometimes you don't. Start with one side, you're working away, getting stuck. Then say, okay, forget it. I'm going to switch and stick to the other side. Go to the other side, see if I can get it from there. If I can't get either one, sometimes somewhere along the way it may happen that the same expression occurs on both sides. So you know you're good at this point. What you're going to do, if this happens, pick one side and reverse each step so it leads back to the other. So you can just reverse the steps. So for instance, if I realized here that I multiplied both sides by cosine and reversing the steps, I would have had to divide by cosine of each. I'm going to talk about the caution as well, since this is, by the way, you can find these in the book. The caution, it says the procedure for verifying the identities is not the same for solving. Right? Techniques in solving, such as adding or multiplying the same quantity on both sides, should not be used. So we're not going to multiply both sides by tangent squared theta, for instance, right? Because then you'd be doing one side. When you're verifying identities, you start with one side and get to the other, leaving the other side alone. For instance, you wouldn't cross multiply. That's another thing you would do for solving equations. So this is a little bit different. We're not asking what theta is. We're saying that this side is always equal to theta, no matter what theta is. So that is the note, the caution that I wanted to go over. So there it is. That's